Hello and welcome to Physics Like a Boss. Our problem is a car accelerates from rest at 2.0 meters per second for 5.0 seconds. And the questions are, what is the speed of the car at the end of this time? And how far does it travel in that time?
With God's help, you can do physics
Physics.
like a boss, as you are created
You are created in God's image.
to be fruitful and multiply.
Fill the earth and subdue. To evaluate this problem, we're going to be using the problem-solving format. So first we start with interpreting the problem. And we have a car, which we're told is at rest at the beginning, and then it's somewhere else at the end, down the road, and it has some velocity to it. So we're going to establish our axis as here being 0, the initial point, and it's traveling rightward for 5.0 seconds to get to its final position. And we are told that the acceleration is 2.0 meters per second squared. All right, so based on this little coordinate system that we've just devised, we're told that the initial velocity is 0 meters per second. And by our system, our initial position is also at 0 meters. And we need to find the final velocity and the final position. All right, so how are we going to do that? That brings us to the develop step of the God has crowned you with glory and honor.
To rule over his creation.
And the information we're given, which in this problem was the acceleration and the time, to determine the final velocity. And we can also use kinematics and the given information of acceleration and time to determine the final position. Science is a gift from God,
To help us master nature,
but sin added thorns and thistles.
requiring the sweat of your brow to succeed.
All right, what do I mean kinematics? Well, now it's time to evaluate our problem. And let's put the kinematic equations up there and see how they fit with the information we've been given and what we're asked to solve. The final velocity can be expressed as the initial velocity plus the acceleration times time. The final position can be expressed as the initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. We can also determine the final velocity as this relationship. The final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in location, the displacement. So we'll just put that one in our back pocket for now. We're given acceleration and time. We know what the initial values for velocity and position are. So those first two expressions are the ones we're going to use first. So let's solve for the initial velocity. We have 0 meters per second as our initial velocity, plus the acceleration, 2.0 meters per second squared, times the time, 5 seconds, 5.0 seconds. Now I'm writing down the units as we go, and the units in this problem were already given in SI, so we didn't need to convert units. Now let's check. Meters per second squared times seconds just leaves us with meters per second here, and a final velocity of 0 plus 2 times 5, 10 meters per second. Learning physics
Often requires prayer
as we submit
to Jesus Christ
as risen.
King of Kings and Lord of Lords.
Now, solving for the final position, similarly, using this second expression, we have our initial position, which is at 0 meters, plus the initial velocity, 0 meters per second, times 5.0 seconds, plus 1/2 the acceleration, 2.0 meters per second squared, times the time, 5.0 seconds, quantity squared. And so that simplifying, we have 0 meters plus 0 meters. Seconds cancel, 0 times 5 is 0, plus 1/2 times 2 is 1, and 5 squared is 25. So we have seconds squared here, cancels out with seconds squared there, leaving us with meters, and so we have 25 meters. So 0 plus 25 gives us the answer that we seek, we think. How do we know if we're right? That brings us to the last step, the assess part of the idea problem solving. We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes
Success in our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor.
In the assess phase of the problem-solving format, we want to figure out if our answers make sense and if there is maybe a computational way to double-check. So first of all, if we consider the final velocity that we computed of 10 meters per second, is it reasonable? Were we expecting something in that range versus hundreds of meters per second or a fraction? Sure. So the magnitude makes sense. That doesn't guarantee that it's correct, but at least it makes sense. Okay, and then we're looking at the sign. Based on our convention in our diagram, we were moving in a positive direction and accelerating, so we expect our final velocity to have a positive sign. And we were careful with our units as we went to make sure that the unit analysis was consistent and gave us the units that we expected for velocity. So we're good there too. What about the final position? Similarly, it has traveled 25 meters according to our calculation, which generally makes sense. So the magnitude makes sense. We were traveling in a positive x direction based on our diagram, and so we have a positive distance. And again, we used our units in each term of our calculation and made sure that they canceled and that we ended up with a unit of distance or of meters, which is what we expected. So we have an internal check there if we carry our units with us to make sure that we're performing our calculations correctly. Okay, what about computationally? Well, we had this third expression that we didn't use for our initial calculations, but we could use it. If we take the square root of both sides, you can compute the final velocity as the square root of the initial velocity squared plus 2 times the acceleration times the change in position, which we now have a number for based on our calculations. So let's see if that makes sense. The initial velocity was 0 meters per second, quantity squared, plus 2 times the acceleration, 2.0 meters per second squared, times, we said 25 meters is what we computed, and the square root of all that. Simplifying, 0 meters per second, meters squared per second squared, plus 2 times 2 is 4, times 25 is 100, meters squared per second squared, square root of all that gives us 10 meters per second. Hey, that matches our initial computation, so that gives us some confidence that we did that correctly. Now what about the position? We can also check the position now as our average velocity times time. So if we take our final velocity minus the initial velocity over 2 times the time, we computed the final velocity as 10 meters per second. The initial velocity was 0 over 2 times 5.0 seconds, and we get 25 meters because the seconds cancels with the seconds in the denominator, and that also checks out. So that may have seemed like we just did the problem twice, but it's a terrific method as physics problems get more difficult as the semester proceeds. Doing the idea problem solving format will protect you from mistakes and help you gain confidence that you've done the work correctly.
Written in the Word, good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Oh, I love Jesus. La 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 la. Oh, I love Jesus.